Dear students, in this video, I am going to explain about lesson number 2, quantum mechanical model of atom, topic number 9, principal quantum number and azimuthal quantum number. What are quantum numbers? The location of electron in an atom is characterized by quantum numbers. That is, the details that are necessary to give information about the exact position of electron in an atom is given by quantum numbers. How many quantum numbers are there? Quantum numbers are classified into 4 types. They are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Here in this video, we are going to discuss about the principal quantum number and azimuthal quantum number. First, before going to the principal quantum number, we have to relate the Schrödinger wave equation with the quantum numbers. When Schrödinger equation is solved for wave function psi, to calculate the wave function psi, while the Schrödinger equation is solved, we have to use the quantum numbers. The solution contains the first 3 quantum number, that is principal quantum number, azimuthal quantum number, magnetic quantum number. Through the values of these 3 quantum number only, the wave function psi is solved in the Schrödinger wave equation. The 4th quantum number arises due to spinning of electron about its own axis. However, classical spectra of species spinning around themselves are incorrect. Let us see about principal quantum number. It is given by the symbol N. What does this principal quantum number denotes? It denotes the energy level in which the electron revolves around the nucleus. We know very well that each and every atom contains various energy level around the nucleus. Here, through this principal quantum number, one can able to identify that how many electrons can be accommodated in different energy level. That is, first energy level can be accommodated by how many electron. Second energy level can hold how many electron. Third, fourth, fifth, so on and so forth. Each and every energy level can be held by how many electron maximum. These details can be given by the principal quantum number. How to calculate the maximum number of electrons present in an orbit can be calculated by the formula 2 into n square. Here n represents the orbit. Let us see the tabular column for 4 orbits. Orbit 1, 2, 3, 4. First orbit can be called as K shell, second L shell, third M shell, fourth N shell. Maximum number of electron in each and every orbit is calculated by the formula 2n square. So 2 into 1 square 2, 2 into 2 square 8, 2 into 3 square 18, 2 into 4 square 13. This table shows that 2 electrons can be present in first orbit at a maximum, and 8 electrons will be there to a maximum level in second orbit, and third orbit can have maximum of 18 electron, and the fourth orbit can hold maximum of 32 electron. So through the principal quantum number, we can able to identify the maximum number of electrons that are present in each and every orbits or each and every energy levels. Here the N principal quantum number is identified by the symbol N. N also gives the energy of the electron. What is the formula to calculate energy of electron? En is equal to minus 1312.8 into Z square by N square kilojoule per mole. Here Z is the atomic number, N is the orbit or energy level. So by knowing the energy level only, we can able to calculate, by knowing the energy level and atomic number for the particular element, we can able to calculate the energy of the electron present in the particular orbit. And the distance of the electron from the nucleus also can be calculated by the formula radius of n into 0.529 into n square by Z Armstrong. Here also to calculate the radius of the electron, that is the distance of the electron from the nucleus, by knowing the n value and the Z value. So to calculate the energy of the electron in different orbit and the distance of the electron from the nucleus, we must want to know about the principal quantum number value. The second quantum number is azimuthal quantum number. It is denoted by the symbol L. The azimuthal quantum number is also called as subsidiary quantum number. L can have the values from 0 to n minus 1. 0 to n minus 1. N means principal quantum number, that is orbit number. 0 லிருந்து n minus 1 வரையும் L value வந்து இருக்கும். Where n represents the principal quantum number, each L value represents a subshell. ஒவ்வொரு எல் வேல்யூ இப்போ நம்ம பார்க்க போகிறோம். ஒவ்வொரு எல் வேல்யூமே ஒவ்வொரு சப்செல் டினோட் பண்ணும். ஃபார் எக்ஸாம்பிள் எல் வேல்யூ மே பி அரவுண்ட் 0, 1, 2, 3, 4 etc. Wherever L value 0 come, it represents the S subshell. Wherever L value 1 come, it represents the P subshell. Wherever L value 2 comes, it represents the D subshell. And whenever L value 4 comes, it represents the F subshell, so on and so forth. So the maximum number of electron that can be accommodated in a given subshell, S subshell, P subshell, D subshell, F subshell we are having now. So how many electron can be held by each and every subshell? That is calculated by the formula 2 into 2L plus 1. 2 into 2L plus 1. It is used to calculate the orbital. This azimuthal quantum number is used to calculate the orbital angular momentum using the expression. In my previous video, I told you about the orbital angular momentum and the spin angular momentum. So the orbital angular momentum can be calculated by the value, by the formula root of L into L plus 1 into h by 2 pi. So only by knowing the principal azimuthal quantum number value, we can able to calculate the angular momentum. So this table shows about the number of electron can be held by each and every subcells in each and every orbit. So let us divided the table into 5 different columns. First column shell, second column principal quantum number n value. By knowing the n value only, the third column, that is L value can be calculated, and fourth column indicates the maximum number of electron present in each and every orbital. S orbital, P orbital, D orbital, F orbitals are there, no? So in each and every orbital, how many electrons will be there to a maximum level. And the last column indicates the name of the subshell or orbital. So shell, K shell means first orbit, L shell second orbit, M shell third orbit, N shell fourth orbit. Okay, so for first orbit, L value will be 0. For second orbit, L value will be 0 and 1. For third orbit, the L value will be 0, 1, 2 based on this formula. L is equal to 0 to n minus 1. No? For third orbit, n minus 1, 3 minus 1, 2. So, 0 to 2 variyum. So, 0, 1, 2. 3 different values will be there. And for fourth orbit, L will have 4 values, 0, 1, 2, 3. As I told you earlier, wherever 0 comes, it represents S subshell. Wherever 1 comes, it represents P subshell. Wherever 2 come, it represents D subshell. And wherever 3 come, it represents F subshell. Based on that, I have labeled the different subshells or orbital. So first orbit contain only one value 0, so it is represented as 1s orbital. Second orbit contain 2 values 0 and 1, so it represented as 2s and 2p. And our third orbit contain 3 values, so they are represented as 3s for 0, 3p for 1 and 3d for 2. Fourth orbit has 4 values 0, 1, 2, 3, 4. For 0 we have represented as 4s, for 1 we have represented as 4p, and for 2 we have represented as 4d, and for 3 we have represented as 4f. So based on the L value, we can able to identify the orbital or subshell. And look at the fourth column, it indicates the maximum number of electron present in S subshell, P subshell, D subshell, F subshell. How to calculate? By using this formula 2 into 2L plus 1. So in first orbit, what is the L value? 0. So 2 into 0 plus 1, which is equal to 2. So maximum of 2 electrons can be present in the S subshell. What about L? L has 2 values 0 and 1. For 0, 2 electrons will be there. For 1, if L value is 1, there will be 6 electrons. So the P subshell will have 6 electrons present in it. For M shell, principal quantum number value 3, azimuthal quantum number value, that is L values, 3 different values are there 0, 1 and 2. For 0, 2 electrons, that is S subshell will have 2 electron. For 1, 6 electron will be there, that is P subshell will have 6 electron. And for 2, the maximum number of electron is 10. It denotes that D subshell will have 10 electron. D subshell will have 10 electron. And for fourth orbit, 4 values are there. For fourth orbit, 4 values are there. They are nothing but 0, 1, 2, 3. and for 0 once again 2 electron, for 1 6 electron, for 2 10 electron. 2 means 4s orbital, 4p orbital will have 6 electron and 4d orbital will have 10 electron. What about 3? 3 indicates 14 electron, which means the f subshell will have 14 electrons. So students, in this table, from this tabular column, we can able to identify the subshells present in each and every orbit and the number of electron present in each and every subshell. So first orbit will have only one subshell, S subshell. Second orbit will have two subshells. Second orbit will have 2 subshell, S and P. Third orbit will have 3 subshell, SPD. Fourth orbit will have 4 subshell, SPDF. S subshell will have 2 electron. P subshell will have 6 electron. D subshell will have 10 electron and F subshell will have 14 electron. So these are the details given by the azimuthal quantum number. Thank you.